Hello everybody and welcome back to class. So we've been talking about volume and we have been talking about volume of a cylinder, and then you went on to volume of a cone. And I must say you guys are working so hard. I'm really happy with the grades that you're giving and the effort that you're showing. So thank you guys so much. And since we've finished those two, we have graduated on to spheres, and that's what we're going to talk about today. So this sphere seems like it's out of place with the cone and the cylinder, right? We've related the cone to the cylinder, showing that it is 1/3 of the cylinder. It would take 3 cones filled up to fill the cylinder. And so, oddly enough, this sphere is related to those other two shapes in some ways. Okay, so we could also say that the base of a cylinder is a circle, the base of the cone is a circle, and then obviously there's many circles within this sphere. So what we are going to show you here is first, given that all 3 shapes have the same radius. The radius of the cylinder, the radius of the cone, and the radius of this sphere are all the same, okay? So these are all related in that way. But I'm going to show you another way, obviously with a little experiment, just as we did with the cone. Okay. And just as we talked before, that the cone was related back to the cylinder in that we could fill this up 3 times to equal the cylinder. We are going to experiment with the cone and see how many cones would equal the sphere. So let's get started. We're going to fill this cone all the way up with water. And then in order to pour this water into our sphere, I'm going to pour it back into a different measuring cup, just to make it a little easier on me. So we are going to fill this sphere up with what we have from the cone. And we're going to be able to see how much of this sphere is filled by just 1 cone. And almost there. So again, we have taken a cone and filled the sphere. So let's try to level this out here. And we could see that 1 cone has filled this sphere halfway. So if you made an educated guess, how many cones would fill the sphere? You would easily say 2, right? So it takes 2 cones to fill up a sphere that has the same radius. But also, if you compare the height, they are the same height as well, and that will come into play later when we mess around with the equation. But 1 cone fills the sphere up halfway. So it takes 2 cones to fill up a sphere, but we said it takes 3 cones to fill up a cylinder. So let's try to relate the 3, right? So if you had 2 cones inside the sphere, and then we pour it into our cylinder, then that would be 2/3 of the cylinder. So what do we know would fill up 1/3 of the cylinder to make it a whole? 1 cone. So again, the sphere filled up and the cone filled up, and you dump it into the cylinder, you have the total volume of a cylinder. All right, so let's talk about the sphere in terms of an equation. So we just said 2 cones fill up a sphere. So if we look at the equation for a cone, 1/3 times pi r squared times height, if we had 2 of those, we should get the equation for a sphere. So let's play around with that. All right, so in order to have two of these, you could do two different things, right? We could add these two together, but I know how much some of us despise fractions. So let's go with multiplication, right? If we had two of something, we could just multiply this by 2, and that's what we're going to do. So 2 times 1/3 times pi r squared times height. Okay, so we're going to get 2 cones and see if it equals the equation for sphere, because I want to make sense of this before I just tell you what the equation is. Okay, so 2 times all of this. Well, what is the difference with a sphere? All you're going to be given is radius. Okay, but think about this height. So we always talk about h for the triangle, but what is height on a cylinder? Sorry, on a sphere. What is the height, right? So this is a radius, this is a radius. You could say two things. You could tell me, Miss Jeffries, the height is the diameter, right? But we don't want to mix in another letter in here. So the diameter is equal to how many radius? How many are? 2. So the height is equal to 2r. Okay, so let's work with that. Instead of writing h, we are going to write 2r. Okay, so again, we still have 2 cones. Okay, so let's multiply this out. We have a 2 here, we have a 1/3 here, and we have a 2. So let's multiply those numbers, right? So this is 2/1, this is 2/1. So when we multiply 2 times 1 times 2, what do we get? 4. Absolutely. And so if there was a 1 on the bottom of this, if this was 2/1, 2/1, 1 times 3 times 1 is just 3. Okay, so our fraction out in front is 4/3. What are we left with? We are left with pi, we're left with an r squared, and then we're left with an r. So what is the exponent of that r? Good. When there isn't an exponent, the exponent is 1. Okay, so we have r to the second power and r to the first. Whenever you multiply, remember we add the exponents. So 2 plus 1 is? Good. So the volume of a sphere when you have 2 cones should be 4/3 times pi r cubed. All right, so you guys have been doing a great job with square, right? R squared, it means a number times itself. What does r cubed mean? Great, so you're gonna take that base number, whatever r is, and you're gonna multiply it by itself one more time. So if our radius was 5, you know if it was a cone, you would say 5 times 5 is 25. All right, but now when you get into spheres where it's cubes, it's 5 times 5 times 5. Okay, so 5 times 5 times 5 is 125. All right, so your sphere, instead of having a height, is r cubed, and the fraction in the front is 4/3. So last thing, let's talk about steps. So we don't have height anymore. So let's change these steps to match what we're doing now for the sphere. All right, and we will make this blue since we're talking about our spheres. So the fraction in front is 4/3. And then instead of multiplying by height, we're going to take it out and we're going to cube the r. Okay, so steps. Number 1, find the radius still, right? If they give you diameter, you still have to cut that number in half. All right, so next, we are not going to square the radius anymore. We are going to cube the radius. Okay, so that means to the 3rd power or to cube it. So cube the radius. And our next step is multiply by h and pi, okay? So before, when we talked about 1/3, you would multiply by 1 and then divide by 3. So that's why we cut out the multiply by 1 step, because that's going to get you the same answer that you already have. And all you had to do was divide by 3. Okay, well now we have 4/3. So remember, you multiply by what's in the numerator and divide by what's in the denominator. So instead of multiplying by h, you're going to multiply by 4 because that's in the numerator. So multiply by 4, multiply by pi, and then you are still going to divide by 3. Because that 3 is in the denominator. And lastly, round and label. So still the same amount of steps, but you're going to cube the radius, and then you're going to multiply by 4 instead of height, because that is the numerator of your fraction for a sphere. All right, so I hope that makes sense. Please answer just a few questions on relating the sphere to the cone to the cylinder on your Google form today. Please make sure you take advantage of retaking the scavenger hunt if you need to, or retaking the volume of a cone worksheet that's also a Google form. All right, reach out to me. Thursday's our day for Zoom meetings. I'm available at 12, 12:30, 2, and 2:30. I'll see you then. Have a good one.